Next up, we have Michael Krotscheck. He works on OpenStack on behalf of HP, and the talk is called Talking to Browsers with CORS. Please welcome him.
Hi, everyone. As she said, my name is Michael Krotscheck. I currently work for Hewlett-Packard Enterprise. This is probably one of the first presentations you'll see with our new branding. I'm not entirely certain I'm allowed to use it, but I don't care. And Hewlett-Packard keeps me working on OpenStack. And to those of you who are familiar with it, it's the topology of the ecosystem is we have all these various different services. And the thing I do inside of OpenStack is I write a lot of JavaScript, and I actually don't really like writing that much Python because I like things that are pretty. And I'm sure that the majority of you people here don't really like HTML and JavaScript, which is what this entire talk is all about. It's about you guys can do all your Python things, and I can do my JavaScript things, and we can talk in a way that doesn't make either one of us crazy. Now, for those of you who want to follow along with the presentation, this is currently published up on GitHub. The URL in the bottom left there also includes it, so you guys can follow along. And the overview is I'm basically going to talk about the history of the same origin policy in XML HTTP request, the way that browser applications generally talk to a server backend. I'm going to talk about how in the past we've had to break this single origin policy, the same origin policy. Then I'm going to go through the core specification, show you an example implementation, and then actually show you the whole thing working, hopefully if I actually have time at the end. If not, I can share that code. So to begin, the same origin policy, it came out in 1995. Now think about that. That's 20 years ago when Netscape 2 first introduced the JavaScript engine. And the point is that if you have a script inside of an HTML page, you're allowed to access the content of other pages as long as the origin is the same. Now, what does that actually mean? It means that a combination of URI scheme, hostname, and port. So if you have this script, this can read inside of an iframe, can read this HTML page inside of an iframe, but it cannot read either one of those three. And the reason for this is so that, you can't do this. So somebody creates a full screen iframe and loads up all your credit card information and then has a keystroke logger. That would be bad, right? So the same origin policy kind of makes sense under the circumstances. And there are some exceptions because of legacy. And if you think about it, that's 1995. We already had legacy exceptions. And at that point in time, the one that is really important is the fact that you can include JavaScript from any other domain, and it will run inside of your page with full privileges. The form post is relatively irrelevant for this particular presentation, but I'm including it for completeness. Second part of this is the XML HTTP request, which has absolutely nothing to do with XML. This quote from Alex Hopman, who was actually working on Internet Explorer 5, is that he actually attached XML to the name so that he could ship it inside of Microsoft's XML lib, which then sort of got ported into Internet Explorer 5 in 1999, so that he could build Outlook Web Access, which we all love, right? We all love Exchange services. This is the origin of this guy, and what it basically lets you do is issue HTTP requests directly from inside of the JavaScript engine. So this top one, like if you're coming from myapp.example.com, you can issue a GET, you can issue POST requests, and you'll get reasonable HTTP requests coming out of that. But then they applied the same origin policy. So now all of a sudden, if you're coming from myapp.example.com, you can't go to a separate API host. You cannot include a third-party service like Square, or a different use case, if you have a mobile application and a tablet application sitting on different hosts, you cannot access a centralized API. So we've had to hack and work around. And we've done some terrible, terrible things to try to work around this particular thing. The first one of these is proxies, of course, where you basically set up a server that takes, you issue your HTTP request to the host that your application is currently running on, and it then redirects it to some other host or domain and so forth, which works, but it's processing overhead because you now have to do this. And the namespaces get really confused very, very quickly. Let's say you have more than one, in this case, Square account. How do you handle that? And then the other issue is, what if the thing that you're consuming is truly RESTful and returns all of its references as fully qualified URIs, which means that now all of a sudden your proxy has to rewrite every single request as it comes through. So that adds additional overhead. And I mean, this is something you could do, but it's a hack, right? Second thing that people started doing is this thing called document domain. Now, this was specified in 2003 in the HTML DOM 2.0 specification as a read-only property. It was never implemented as read-only. And the reason this works is because XML HTTP request accesses this to determine whether or not it's sitting on the same domain. So if you have two iframes sitting in your web page from these two different APIs, these two can issue privileged HTTP requests to those domains. And then if the encapsulating HTML and each one of those themselves set this document domain property to the parent domain, to the TLD, that will actually work. At that point, every one of those pages thinks that they are living on example.com rather than subdomain.example.com, and you can reach into the iframe and talk with that, which is a little bit of a security hole, if you kind of think about it, right? So that's something we started doing in 2003. And then people said, you know what, let's formalize this. Formalize. Actually, no, I'm entirely wrong. And then they decided, wait a second, there's this legacy exception in XML HTTP request where we can actually we can make DOM manipulations and include JavaScript directly in our page and then remove it. So what you would do is you would manipulate the DOM to issue your GET request, and then add this callback on the end and said, all right, when you come back, I want you to wrap the response, the thing that I asked for, in JavaScript. Because that makes sense, right? And now you have all these crazy DOM manipulations and what happens if things time out. And so this is also a bit of a hack. But you know what? Let's formalize this hack. Let's formalize it, and let's call it cross-document messaging. And this was the WhatWeG org. This came along in 2008. And what they decided to do is, instead of explicitly saying, hey, give me a callback, they said, we're going to create an event broadcasting mechanism between iframes and between different frames. So in this case, what you're seeing is the child iframe is adding an event listener, and then the parent that includes this iframe inside of it, posts a message to the child iframe, and the child iframe can then receive that. And there's some suggestions about, you'll see this property here. That's the domain property, and you're supposed to validate that, but there's nothing actually enforcing that you do that, right? So now this is a specification, and we've taken something that was a hack to begin, and we've set it in stone. And then WebSockets came along, and they finally said, you know what, this is all optional, we don't care. Single origin is dumb. Because WebSockets don't even validate this kind of stuff. We're just going to create a socket. You should include the origin. The server might validate on that, but in reality, we don't really care anymore. And this is in 2011. So now in 2014, now this was approved in 2014. It's been implemented for a few years before that in various different browsers. This thing called cross-origin resource sharing came along, where they finally decided, yeah, we're going to fix this, and we're going to fix all these legacy concerns. And the protocol basically has two parts in it. It's an HTTP protocol, so it works entirely with HTTP headers. And the first thing that happens is you have this pre-flight check. And this is your JavaScript application asking, mother, may I? I want to do this thing. Am I allowed to do this? And the services then will respond in a way that either indicates yes or no. And then the follow-up to that is the actual HTTP request, which also needs to be validated. So if the server comes back and says, yeah, you're allowed to do this, but then it doesn't actually allow you to do this, then it will still fail, right? This pre-flight check looks basically like this. And this is implemented in all modern browsers. You don't even have to worry about it anymore. It's an options request. Let's say I'm making an HTTP call against options billing cards. And the thing that the browser adds is this origin. And it's saying, I live on this domain. And it's saying, I want to perform a GET request, and I want to send you these two custom headers. I want to send accept, and I want to send this custom header called xClient. And then the servers, so the server's response will say, yes, you're allowed to do it, by telling you this is the allowed origin, and this is a comma-separated list. You can have an arbitrary number of domains in here. Wildcards don't work. You're allowed to do a GET request, again, comma-separated list. And these are the headers I'm allowing, and some additional information. This allow credentials says you're allowed to send authentication credentials of various auth headers. And the last one's interesting because that indicates caching. So this pre-flight request, this mother may I, is cacheable for a certain amount of time so that you're not flooding your API with double the amount of requests, because you don't really want to have an options and a regular request for every single thing that you're trying to do, which is why you want to cache this. And then the real exchange, when you're actually performing, in this case, a GET request, again, includes the origin and includes those two headers that you referenced earlier. And then the response is it's basic HTTP response, and again, it has the allow origin, it has the allow credentials, and it has this last one, this expose headers, which is, by the way, I'm also sending a whole bunch of headers, and you are allowed to read this list. So you can kind of see, like, at the end, there's content language, expires last modified pragma. If your API sends out custom headers, say API version headers, you would want to include that in this list so that your client can do API version notification. There's one wildcard available inside of the CORS specification, and that is the single star. And if the access control allow origin header comes with a single star, any domain, any application on any domain is allowed to access this particular resource, which would be nice. It's nice if you want to provide an API to everybody and you don't really care who signs up, right? It's not so nice if you want to keep tight control over who's making what requests from where. So personally, I try to not use it. OpenStack's recommendation is that you don't, because it can be very easily abused. Let's say you're building a client application that's JavaScript and HTML, and some malicious individual copies it, attaches a keystroke logger, puts it onto a compromised domain, and then somehow manages to redirect you to that. All of a sudden, they are getting everything, and they're allowed to access your API and make it look like a fully functional application because everything works, but they're also listening in on the entire exchange. So not having that star in there is something I personally recommend. Implementing CORS. Now that we've kind of gone over the protocol, the very, very quick way of implementing it is just add the headers with your web server. Apache has mod headers, Nginx has add headers, whatever. I'm sure that every single web server you might use out there has a similar extension that will allow you to just add the headers statically, and then they will come back with every single request. But if you want something a little bit more customized, there's a whole bunch of different Python packages that support this. This is just a really quick search on PyPy for what's available out there. Personally, I'm personally invested in Oslo middleware because I actually wrote that particular piece of middleware, but that is in use inside of OpenStack proper, and it has some dependencies on the Oslo configuration that you might not want to have in your application. But then the one I'm not covering here is that if your application registers domains from which applications are allowed to make requests, you'll probably want to copy whatever logic is in any one of these and add your own database backend that has registered origins and all this other stuff, right? Just to give you an idea of what this looks like, this is Oslo middleware. There's a link here. You guys can look directly at what that code does. If you're really curious about the implementation itself, you can actually, documentations talk about, this comes from the CORS specification 6.1.1 and so on and so forth. Feel free to copy that verbatim into your own code if you are so inclined. And It's Apache licensed, so, I mean, use and reuse and do all the happy open source things, right? So I'm going to try a demo, and I'm going to do something a little bit crazy on this demo because I'm going to go to a website that is hosted on GitHub. It's currently hosted on GitHub. It's krotscheck.github.io/ironic web client, and it's for a project inside of OpenStack called Ironic. And as you can see right now, it doesn't know where to go at this point. It doesn't have a configured API. So I can say, I've got this running on localhost, which I actually don't. And I'm going to go localhost and 6385. And you'll see it's making a whole bunch of connection refused. It's attempting to detect it. It's not succeeding very well. So I'm going to go ahead and start up the API. There we go. And I'm going to try this again. 8, 5. There you go. And now what you're seeing here is no access control allowed, origin header is present. So it's already trying to make this XML, this CORS request. If you go into a little bit more detail, you can kind of see this 405 failed, and you can look at the headers and say, all right, we have get, we don't have origin headers, and so forth. You'll notice that the origin header is actually sent by the browser. That's down here, right? And that's because I didn't actually activate the middleware. Now, the middleware I'm going to use, as I said, is this thing called CORS middleware. I'm going to go ahead and activate it, and I'm going to add a domain, or add a permitted origin, krotscheck.github.io. And I'm going to permit credentials and basically add the configuration options necessary to make this actually work. And then I'm just going to go ahead and restart the server. There we go. And if I try 85, it just passed. You see there's the options request. There's all of our allow credentials headers. The browser has acknowledged that this request is allowed to cross this same origin policy. I'm going to save. And there's our UI. And as you can see, we're starting to load data from an API that is running on my local host, but the application itself lives out on GitHub. This might seem a little bit strange to you, but now if you think about it, in the cloud world, what if you have two different clouds that you are trying to manage? I have one Ironic client, and I have my internal cloud, and I have my external cloud, and I've got instances across both of them. Well, being able to break that sandbox and talk to both of them in one single user interface is a pretty powerful statement, because you don't have to deploy more than one app, and then you can, add another one if you really wanted to, yet another cloud. And this doesn't. I tried using this against an internal version of Ironic. The versions are, a HP version of Ironic, and the versions are out of date, so this particular client doesn't know how to talk to it, but otherwise you would be able to do that. So I can do that again, and now we have, two, and then we go and we launch it and switch between them if you really want to. So that's CORS in a nutshell. That's the demo. There's really not much to it. It's a fairly straightforward protocol and headers, and it does work. And this is how I, as a JavaScript developer, would really love you guys to implement, or I want this support on the API so I can build all kinds of crazy applications without having to talk to you and without actually having to look at your code. Well, no, I mean, think about it. It's friction, right? It is cognitive friction to have to go switch context to another language. Questions? No? Wait, we have a question.
You might have mentioned this and I missed it, but you expose that CORS information once on the root, or you expose that per path?
CORS information.
So the options.
In the application itself?
So, I mean, options had all of the allowed methods.
Yes.
You do that once on the root, and you just assume that covers everything, or you're supposed to expose that like this specific path takes post and get?
It's once per path. Every single request will Every single path, every single request will do that. Now, the original, if I can, let me switch back to the headers real quick. What you can do is when this thing comes back, this can be a comma-separated list. So you can batch the methods on a particular path, and you can batch the domains on a particular path. I recommend you set up this very origin up here, because that will cause the internal caching mechanism of a browser to change if you're looking for a if you're using the same API from two different applications, right? Any other questions?
You show a permissive response, but you don't show a response where, no, you can't do that. Is it a 406? Is it a 403?
It doesn't matter what kind of HTTP response you get. If the headers aren't there, the browser won't even let you add it. I can actually demonstrate that since we've got plenty of time here. Let's say I do not want to allow the accept header. And let me restart this. All right. And we are now in, where is it? Just a moment. Let's close all these. And you'll see that's failing, even though it's coming back as a 200. The response headers doesn't include anything. And this is actually in the specification. There's a whole series of steps. It's like if this is a registered domain, if this is not a registered domain, fail. And every single failure condition is basically do not include the CORS headers and exit.
It'll still return a 200?
Yeah, it's still returning a 200. There's one dangerous thing to do with this. If you're doing it via middleware, the action will still occur. So if you're issuing a post request, against, and the middleware will say, okay, well, I'm just going to pass this through to the application, and then it comes back, and, well, I guess I'm not allowed to attach any CORS headers, so I'm just going to let it through. But the action still happened. There's nothing in the CORS specification that prevents the request from doing anything. It just says when it returns and it's permitted to break this box, attach these headers. That's all it does. Another question?
I'll preface this by saying I didn't really know much about CORS before coming here. But is this, for instance, if you sign up using the Dropbox API, you say, I'm going to be using Dropbox from this domain. Is this what it relates to? Is that adding this CORS header, or is it something else?
That's two things. I believe it's adding the CORS header so that they know where you're going to be coming from, but it is also part of the either the OAuth or the OpenID specification, because that requires an additional domain key. It requires the response referral domain so that you can get an auth key.
Right. And the second question is, what's the actual procedure when you say this is cached for 1 hour, but if you lose access to it within that cache period, and it was going to fail?
Then the response request itself, so not this guy, so this one's cached, but this one should not include the headers, the response headers, and then you will no longer have access to that.
Some more relating to that with the GitHub situation. Mm-hmm. Does that make, in that situation, if you had a whole bunch of sites pointing at GitHub, if you did a CORS request, you would get back a list of all domains that are allowed to access that? Is that correct? Because that's a kind of a leakage of here's everything that's allowed to access this, and here's a bunch that aren't me that I now know about.
Right, so that depends on the implementation of the middleware or whatever you have that's responding. The naive implementation of just using mod headers, you can add as many domains, and yeah, that would be a little bit leaky, right? That's going to expose customer data. The middleware that I just showed you only returns the domain that you requested it from, assuming that it is permitted. Otherwise, it doesn't let you know anything.
I guess it kind of follows up a little bit. What confuses me still is like we've been told not to really believe anything from the HTTP headers. So in what way do what security really does the whole "this is my domain where I come from" really brings, especially if someone like just does a wget or whatever?
To that, I would say that as a JavaScript engineer, we assume that nothing is secure. Because nothing is, especially if you are on the other side of the Great Firewall. I mean, every single request that you make is likely to be compromised. I live in the United States. The NSA is listening to everything that I do. So is there a chance that these headers are legit? Yeah, it's a chance that they're not legit. There's nothing you can really do about that. The only thing you can really do is make sure that when the request hits your server, you do all the necessary validation. Make sure that, assuming this is a proper request, it all goes through, right? And that's input data validation, so. Anything else? All right, thank you very much, everybody.
Thank you.